Civil engineer Sir Gilbert Roberts was tasked with building a bridge across the River Severn. His biggest innovation was a windproof bridge deck.
If you look at the shape of the deck, you can start to get a sense of what the solution was. And the most amazing thing is that the shape of this bridge deck and the solution they came up with was actually a happy mistake.
Sir Gilbert Roberts broke his original truss lattice design while testing it in a wind tunnel. As he waited for a replacement model, he researched the aerodynamics of other objects, leading him to a truly groundbreaking idea.
So what I have here is a model airplane, and you can imagine that the wing of this airplane is representing the bridge deck. So a wing has a curved surface on the top, and it has a flat surface on the bottom. And this means that air passing over the wing has to travel further across the top than on the bottom.
As air passes over the curved surface, it speeds up and loses pressure. The pressure of the air below remains high and pushes up towards the low pressure area, creating lift.
What I'm going to attempt to show you is with this hairdryer to generate some wind, the force of the little model airplane will decrease, and that decrease will signify the lift force that we've generated on the model. So there we have our starting weight, 45 grams. Right, so there we go. The engineers here didn't want that to happen to the bridge deck.
When Luke flips the airplane over, the lift effect is reversed, creating a downward force.
What we should see is that this force should increase rather than decrease. You can actually see the downward force that's coming from the wind. That holds everything nice and taut and safe in very strong winds.
Now that the curved surface is underneath, air loses pressure as it speeds up, and the high pressure above presses down.
And of course, this is exactly the principle that the engineers used on the Severn Bridge.
Sir Gilbert Roberts and his team created an aerodynamic steel box girder deck, the first of its kind in the world. Hollow and only 10 feet deep, the shape of the deck creates a wind flow that holds it firmly in place. Over the years, 13 vehicles have blown over while crossing the Severn Bridge. But the bridge itself has always held on strong.